Okay, so a projectile is launched at an angle of 30 degrees at a velocity of 20 meters per second. What are the horizontal and vertical components? So if I scroll down, I've got this drawn, and what we have is a velocity of 20 meters per second at an angle of 30 degrees. So that arrow, that solid arrow, is the resultant, basically. So it's a little bit different from yesterday, where yesterday we had multiple vectors adding together making a resultant. We're kind of doing it a little bit backwards here. So in this case, the main vector is the resultant, and we want to look at the components of that resultant in the x and y direction, the horizontal and the vertical direction. So we have a velocity, an initial velocity at time 0, which is 20 meters per second, at an angle of 30 degrees. Well, we have a velocity, an initial velocity in the x direction. Okay, this is the way I'm going to annotate. I have a velocity at time 0 in the y direction. And so what are those things equal to? That's what we are asking for here. The first thing to get there is I'm going to show you some math trig stuff. I know that not everybody has the same background in math, and there's some of you that probably have never seen any trig stuff before. And so I'm going to go through that step by step and relatively slowly here. And that's why I'm recording it, so that way you guys can go look at it later. So I'm going to, first off, start by doing this. SOHCAHTOA.
Yes.
This means that the sine of an angle theta, theta just means an angle, whatever the angle is, and in this case it's 30 degrees. So the sine of the angle theta is equal to the, and I'll just write it out, opposite over the hypotenuse. So the sine of the angle is equal to the opposite over the hypotenuse. And the question might be, what the heck is a sine? Okay, it's not a stop sign or yield sign, it's just sine. It's something that you plug into the calculator. That's probably all you need to know. What you also need to know is it is not multiplied. Okay, that's the one thing you need to pay attention to. It is not sine times theta. That's not what it is. Okay, so you can't divide out the sine or anything like that. It is, when you put it into your calculator, you're going to have this. Okay, that's what happens when you hit the sine button on your calculator. So in this case, you would have to hit 30 degrees and then close the parentheses. You must close those parentheses in your calculator. All right, so if I want to find the opposite side, and this is the opposite side here, right? Right there we have the opposite side. If I want to find that opposite side,
Yes.
I want to solve for the opposite side. So I'm going to multiply each side here by the hypotenuse, and now from here on out I'm just going to abbreviate just by using the first letter. So that means that the opposite side is equal to sine of theta times the hypotenuse, and that equals the opposite side. If I look at this triangle here, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So that means that the last thing I need to do is this, that the sine of 30 degrees times the 20 meters per second is equal to some value, and if you plug that in, you would actually get 10 meters per second. If you put that into your calculator, you get 10 meters per second. The sine of 30 is 1/2. So the sine of the angle times the hypotenuse, which is the 20 meters per second, is going to give you the opposite side. That is the initial velocity in the y direction. And every single time that you want to find the velocity in the y direction, you use sine. That's every single time, at least with what we're going to be doing. Okay, with what we're going to be doing, every single time you want to find the vertical, you use sine. So that every single time that you want to find the vertical, or the y component, every single time that you want to find the y, the up and down part of that triangle, you use the sine. The sine of the angle times the hypotenuse will give you that side. Okay, the sine of the angle times the hypotenuse will give you the opposite side. And the initial velocity in the x direction is actually going to be equal to the cosine of theta times the hypotenuse. And again, I have to put my parentheses around that. And that's going to be the adjacent side. Okay? The cosine of theta times the hypotenuse is equal to the adjacent side. So if we plug in our values here, this means that the initial velocity in the x direction is equal to cosine of 30 degrees times the hypotenuse, which is 20 meters per second. And that gives us a value of, I believe, 17.7, if my memory serves me correct. Okay, my memory is terrible. 17.3 meters per second it is. All right, so we have the lengths of these two sides. We have 10 and 17.3. So if I go back up, I can say that this is a 10 meters per second, and this here is a 17.3 meters per second. And keep in mind that that is an initial velocity. At the moment when it is launched, yes, it has an angled velocity of 20 meters per second. But if I break it down into its components, it's a horizontal component of 17.3. It's a vertical component of 10 at that moment when it's launched. As time goes on, only one of those components will change. The x and the y velocities. Only one of them will change. Which one is it? It's the vertical. The vertical, the y component, will change, not the horizontal. The horizontal will continue forever, except for air resistance and when it hits the ground. But we are neglecting air resistance right now, so it will continue on in that x component.